Today, we've got something truly incredible to share. The chance to see the northern and southern lights with the naked eye from all around the world. So, what caused this extraordinary event? A very strong solar storm affected Earth's magnetic field, creating a spectacular visual display. The sun is reaching the peak of its 11-year activity cycle. This means we can expect more explosive outbursts of particles. Under the right conditions, these particles create the beautiful auroras in the sky and geomagnetic storms that can damage our infrastructure. So what's actually causing these phenomena? Normally, the northern and southern lights are confined to very high and very low latitudes. High-energy particles from the sun are directed towards Earth by the solar magnetic field. These particles transfer to Earth's magnetic field in a process known as reconnection. These fast and hot particles then race along Earth's magnetic field lines until they collide with neutral, cold atmospheric particles like oxygen, hydrogen, or nitrogen. At this point, some of their energy is lost, heating up the local environment. However, these atmospheric particles don't like being energetic, so they release some of this energy as visible light. Depending on which element is heated, different wavelengths and therefore colors are emitted in the visible light range. The blues and purples in the auroras come from nitrogen, while the greens and reds come from oxygen. This process happens all the time, but during strong solar events, auroras can be seen at lower latitudes. So why were we able to see the auroras further south this time? The sun's strong activities can compress and release Earth's magnetic field, pushing the magnetic field lines closer to the equator, allowing auroras to be seen further south. Strong geomagnetic storms can generate currents in anything that conducts electricity, posing a significant threat to modern infrastructure. Power lines, train tracks, and underground pipelines are at the greatest risk. The geomagnetic storms on May 10th and 11th were exceptionally strong, with the potential to induce large currents. In 1989, a geomagnetic storm melted a power transformer in Quebec, Canada, causing hours of power outage. Since then, protections have been added to power stations. However, metal pipelines are still at great risk and can corrode when an electrical current passes through them. This is a slow process, but can have a significant impact on infrastructure and is difficult to detect. That's how a strong solar storm affects our world and creates stunning auroras. Don't forget to subscribe to our channel for more exciting science and space news. See you in the next video.